Okay, I'm going to talk about how global warming is threatening our planet and what we can do to stop or reverse global warming without going to extremes like geoengineering. We have answers that are right in front of us, and look, the answer is right here. Thorium is the answer. Why thorium? Why not the current uranium plants we're using? The current uranium plants are inefficient, dangerous, and we are almost depleted of our current uranium stockpile. But there's many kinds of uranium. Uranium-233 is made from thorium, and thorium is very readily available. The uranium that we're talking about is uranium-235 that is very rare. It is a rare earth mineral, rare earth. And thorium is as common as lead, and thorium is a common element. And is on the periodic table of elements, and is known as Th element. Thorium, see? Right here. And thorium is great as an energy. And it was discovered in 1828 by, let's see, let's go to Wikipedia. It was discovered by, let's see, by Morton Thrain Esmark and by John Jacob Berzelius. And it was named after Thor, the Norse god of thunder. Well, I don't know why they didn't just name it like an element name, like something like, I don't know, like give it a scientific name. Why did they give it a religious name? I don't know, but that's not important. But maybe that to make people just like understand it more, because like with mythology. But the Th element, LFTR, liquid thorium fluoride reactor, and how thorium is gonna change our life. Thorium, see why cycling worse would be an even worse idea. There's always these critics about thorium, you know. Well, let's go to it. I mean, you can't just. Some LFTR supporters seem to be that far more than just base load power. Okay. Thermal coefficient. Unbelievable. Oh, great. Always with these critics. They're now developing them in India and in China, and they're very successful. And yet these critics are... Why cycling? Oh, power cycling. Oh. You know, freeze valve, thermal fatigue. They should just develop a better. Even if the freeze valves are having problems, they should just design a better one. Ugh, all these critics are just unbelievable. All these pessimists. See, thorium plants could easily meet or exceed these estimates. There's mostly benefits of thorium. There's very few risks, especially that it does not melt down. Okay, the element. Okay, LFTR benefits. Just read some of them, and see. And the risks didn't include meltdown, because they are meltdown proof. See, benefits of LFTR. Low cost, eco-friendliness, and speed of development. And everyone knows that hydroelectricity is the cheapest available, even cheaper than coal, but it's not it's only available where water is. Well, LFTRs are even cheaper than coal and hydroelectricity, if it's used the right way, of course. Okay. I'm going to highlight this so it'll be easier to read. Here we go. Since LFTRs operate at atmospheric pressure, there is no danger that if it depressurizes of a major explosion like in Fukushima Daiichi plant, because they didn't need. And look, just yeah, maybe it'd be better, and I'll explain what this means. So, molten salt reactor. Thorium is naturally liquid at room temperature. Well, and there's a freeze plug which as it says here, that keeps it as a solid. And should the generator break down, laws of physics and thermodynamics will reduce the reactivity and melt the freeze plug to take the reactor salts to the drain tank, which never switches off. Of course, gravity never switches off. If all electronics are lost, as happened in Fukushima, cooling off the freeze plug sees it, and once again the core salts move down to the drain tanks. See? Inherently passively safe. And if you want more information, and then just words, the name of this website is LFTR. Yeah, this is LFTR. LFTR. Hold on. I don't know if you can see this. It's HHTP. Oh no, it's LFTRSUK.blogspot.com/benefits of LFTRs.html. But if you want more information, please go to LFTR in 5 minutes. I mean, it's really 2-hour video. And that's Kirk Sorensen. He is a thorium activist. And also, he's now running his own energy company. He also used to work for NASA for the space program. That's correct. And there's a petition on whitehouse.gov to petition the Barack Obama administration to tell the Department of Energy to stop the destruction of uranium-233 that was created by thorium, by doing experiments in the 1970s. But I'll get to that later. If you want more information on this petition, go to www.thoriumpetition.com. It's one word. Thorium. Petition.com. Oh, I hate when this happens. It always freezes up on me. Thorium petition.com. This is a one word. It's a one word. Thoriumpetition.com. See? If you're a United States citizen, please sign this petition. And once you click here and subscribe to the mailing list, I've done it, and I would say they do not spam. They only see if 25 as required by we will relaunch and alert subscribers. They only email you once a month. They do not spam, and they only email you once a month if the petition does not go through. And unfortunately, I checked recently. There's only like 1,500 signatures. It's not doing well at all. I've tried everything I can to alert more and more people about this petition. Of course, I did not create the petition. I'm just trying to get people to sign this petition so Barack Obama and his administration can do something about it. Because with thorium, we could end the wars over oil, we could end the wars over energy, and we could avert the energy crisis that everyone is saying is going to happen in the next 50 years. Because we have enough energy to last us for tens of thousands of years if it is used correctly. And no, it is not solar energy. As solar energy is invasive. Wind energy is dangerous to birds, and hydroelectricity could lead to floods. The only good option, short term at least for the stepping stones of humanity for the next couple thousand years, is thorium. Thorium. We are running out of fossil fuels. We're running out of our current nuclear stockpiled nuclear energy. The uranium plants that are currently operating. Uranium is the uranium is found in nature. We're running out of it. We're using it like it's found every day. It's not. Thorium is, but we're not using it. We're using it, the rare stuff. We're using the super rare stuff. And I will even show you. I'm going to go to that video. And he's going to... I just hope... I'm going to skip to the part where he talks about how common thorium is. Kirk Sorensen. And how good for the environment this is. Global warming is a big threat to humanity. Huge threat. And I saw the documentary Earth 2100, and I definitely do not want that to happen. And if you are all worried about climate change, then please, see? Earth 2100. It scared the heck out of me. And I really, really do not want Earth to suffer. And for this, I am petitioning the Thorium petition. This is for stop global warming. And see, I only have 5 minutes left until my limit
The heavy
goes
water
up.
reactor will use about 0.7% of the uranium's energy value, and the light water reactor will use about half of 1%. They both do terrible.
At normal pressures, water will boil at 100 degrees Celsius. This isn't nearly hot enough to generate electricity effectively. So water-cooled reactors have to run at over 70 atmospheres of pressure. You have to build a water-cooled reactor as a pressure vessel.
The number one accident people worry about, pressure is lost. Water that's being held 300 Celsius flashes to steam. Its volume increases roughly by a factor of 1,000.
If you don't get emergency coolant to the fuel in the reactor, it can overheat and melt.
This is what drives the design of this building. So if this happens, all the steam is captured in this building.
Now, the reactors we have today use uranium oxide as a fuel. It's a ceramic material, chemically stable, but not very good at transferring heat. If you lose pressure, you lose your water, and soon your fuel will melt down and release the radioactive fission products within it.
So they have a series of emergency systems
Designed to always keep the core covered with water. We saw the failure of this at Fukushima Daiichi. They had multiple backup diesel generators, and each one probably had a very high probability of turning on. The tsunami came and knocked them all out. And people sometimes say, is nuclear energy safe? And the first thing I say is, well, which one? Thousands of different ways to do nuclear energy. Is the car safe? Well, which one?
I had the good fortune to learn about a different form of nuclear power.
The liquid fluoride thorium reactor.
We can fully burn up the thorium in this reactor versus only burning up part of the uranium in a typical light water reactor. It's not based on water cooling, and it doesn't use solid fuel. It's based on fluoride salts as a nuclear fuel.
I'm gonna skip ahead a little bit. Okay.
That correlation becomes absolutely meaningless now because one is running all the time and the other one is only running 1 out of 6 times. If you had a car and you thought, I'm going to go out and get in my car and turn the ignition, and I have a 1 in 6 chance the car is going to turn on, how useful would that car be to you? The wind industry says, that's okay, Chelsea. You need to have 6 cars. Energy is all about reliability.
Can we address those concerns by using batteries? Audrey, you set up
consume.
Start a rare earth mine in Missouri.
Yeah, see, this is what I wanted to show you.
Imagine carbon-neutral gasoline and diesel, sustainable and self-produced.
You can see that uranium-235 is like on par with silver and platinum. Can you imagine burning platinum for energy? And that's what we're doing with our nuclear energy sources today. We're burning this extremely rare stuff. And we're not burning thorium. Some people are kind of environmentalists, and they say, listen, nuclear power is not sustainable. We're going to run out of uranium. Okay, I will yield that point to you if we're talking about today's nuclear technology.
In 2007, we used 5 billion tons of coal, 31 billion barrels of oil, and 5 trillion cubic meters of natural gas, along with 65,000 tons of uranium to produce the world's energy.
So I have a friend who's trying to start a rare earth mine in Missouri. Jim, how much thorium do you think you'll be pulling up a year? He goes, I think about 5,000 tons. 5,000 tons of thorium would supply the planet with all of its energy for a year. And he goes, and there's like a zillion other places on Earth that are just like my mine. It's a nice mine, but it's not unique. It's not like this is the one place on Earth where this is found. Every time mankind has been able to access a new source of energy, it has led to profound societal implications.
And you see, this is why we need thorium. We are burning all the rare stuff. We are causing all this climate catastrophe, yet we could prevent it. We have the power to stop global warming. People, politicians, do something about this. Stop burning the uranium-235 and start doing the thorium. Thorium is meltdown proof. Come on, people, get your act together. We're running out of time here.